One of our goals as planners is always trying to predict the future and where is it going to go. The type of model that we're using here is an outgrowth of a real-world problem in Barcelona when they were planning for the '92 Olympics. They had a transformative event that they were very concerned about how they were going to manage it all. And so they built a mesoscopic model, much like the one that we've built here in the region, to start asking what-if questions of, how much bus service do we need? Where does the stadium need to be? But also all these other multimodal aspects of pedestrian, bus, rail. How do they move people from A to B, and how do they avoid disaster? And how do they predict the future very accurately in a very short time frame? And that's where these types of models actually grew out of. The Gateway Cities three-tiered model is really at the cutting edge of traffic analytics throughout the country. It's the largest mesoscopic model ever built, one of the most complex ones ever built, and it's truly unique. The genesis behind the need for the three-tiered model was to coordinate a lot of the modeling activities that had been developed for separate projects throughout the region. And part of the STP's goal was to take these disparate models that were created and kind of stitch them all in together into one. And then by expanding from the macro level down to the micro and creating these three tiers, it gives them an analytical capability that they haven't had before.
The cities are usually focused on their project and their footprint. To get the information and data outside that footprint becomes very complex. The model basically provides that data to them to cover really what it is that's outside their control, yet it's collaborated and consistent with the regional plan.
The beauty of this model is it combines the regional issues through traffic growth and even very individual city level issues of testing more detailed impacts at the city level.
The model has the capability to look at the tried and true. We're going to tweak things from a geometric and facility standpoint, but it also has the ability to look at mode shifts. And what if we increase transit dramatically? What if we add new technologies such as automated or connected vehicles? What does that do?
If you do a what-if scenario with the model, you're going to see how traffic gets redistributed and what the impacts of that are.
It also is going to give them a superior analytical capability. Not only is it more detailed, but it also is regional, so they can see the effects of what they're doing on other cities, or see what other cities are doing on their system. So it's insight into each other's projects that wasn't there before.
When you look at an individual development or an intersection for that matter, you have to know how it interplays with everything else. You're evaluating a development project, say in our case at the Atlantic and Firestone intersection. It was being evaluated and designed by both the city and the developers so that it could take advantage of a future transit station across the street. So it could take advantage of the road improvements that are there. So while at the same time we're creating plans for things that will be built 10, 15, 20 years down the road, we're also trying to create new development that's adaptive enough that can take advantage of these new plans in the future.
The value of having the model at this time is you can validate the projects within the STP. You can model that they're reducing congestion, they're reducing delay, and it also feeds into the air quality model to show that you're demonstrating air quality improvement.
I think one of the real benefits of this model is that it is so large and so comprehensive. It's 2,300 signals. It's the largest mesoscopic model built in the United States of America. And it gives the cities a real tool that's cheaper and faster and stronger than any other analytical tool they've had before, because the entire Gateway Cities region is replicated within this model, not just at the freeway, which we've had before, but at the arterial level. With each signal system, each controller, each lane pocket, everything is in the model already. And so going from a kind of regional perspective to a very city-centric perspective, the model has that capability already built in.
Traffic modeling of the STP will help the cities to strategize and actually enhance their own transportation planning and working with neighboring cities to connect the dots.
A large, very detailed traffic analytical tool has been built for every city, and that in the future, when they have a project that they want to test or an alternative that they want to look at, they could just pull this off the shelf and much more quickly, much less expensively, they can do the analysis that they would normally have to start from scratch on and create a whole new model. All the geometrics of all the city streets are perfectly replicated And if they want to go one layer down to create more detailed microsimulation models, all that framework's already been created. And to me, that's part of the real power of this model and the legacy going forward. I don't want the model to be a black box. I want it to be accessible. I want it to be understood, that the capabilities there are real, and that it's not something that's far away, it's here today, that each city understands how it fits into their planning process. The Gateway Cities itself is leading the way in traffic analytics in Southern California.